So, hello guys. The last time we were checking for the Unix. Uh, let's take screen here. In the last video, I was checking for redirecting in Unix operating system, and in this, we were learning about the input-output redirections. In this video, I will check for the Unix Linux shell functions. So let's remind ourselves that in Bash, for example, as you remember, we created a directory called sample directory, and in this sample directory we have the Bash files, and let's create another Bash file called functions bash.sh. We created these functions underline bash.sh, and now we actually let's look how we can actually create functions. So for example, to define a function in Bash, we have the name of the function, we have the opening and closing parentheses, and we have the curly brackets, opening and closing curly brackets, and we have the function inside. So let's see that we have, for example, let's say we have a function called we have a function called func1, let's say, opening and closing curly brackets. And now inside this function, we actually, let's say we want to echo something, let's say hello world. We want to print this on the screen. And now to call this function, we actually need to invoke this function. We just need to say that, like, we just need to put the function name here, and that's all. Let's quit it. Let's make this function.bash functions.bash executable. Now we can actually execute this. As you can see, the hello world is printed, and these functions can also take some parameters. For example, let's say we have another function, functions bash2.sh. Let's put the shebang here, and now let's say we have let's say hello2, opening and closing brackets. And now if you want to, let's say you want to echo, for example, echo hello world, or hello world. Now the variables variables 1 and 2 will be replaced with these ones. So when you actually execute this hello2 function with two different variables, let's say variable 1 and variable 2, now actually let's make it executable. bash2.sh, now you have the name, the first variable and the second variable, so returning values from functions. So instead of like quitting the function, you can actually return variables from the functions as well. So how to return a variable from the function? So normally you have for example, let's open the previous file again, function bash2.sh. Now, for example, when you have a return, let's say if there would be a return statement here, this actually would, if there would be like an exit keyword here, if there's an exit here, let's see what's going to happen. It's going to print it, but the exit keyword is actually, we have the exit keyword is actually leaving leaving everything behind. So let's say that we have, let's say, another echo hello world 2. In this case, we will not see the another one opening because it's going to basically quit the previous function as well. So let's see, returning values from functions. If you execute an exit command from inside the function, its effect is not only to terminate execution of the function, but also of the shell program that called the function. So exit also closes the shell program as well. So if you instead want to just terminate execution of the function, then there is a way to come out of a defined function. So this is called the return. So how we do that? So let's create another function, bash, let's say bash3.sh. Here we have, let's say, func3. We have func3 here. Now let's say this func3 actually basically prints something on the screen, right? Hello world. These are variables that actually replaces your stuff. And now we have the return, let's say return 10. Now when you actually invoke your function from here, let's say you want to invoke this func3. You want to invoke this func3 with two variables, variable 1, variable 2, and we invoke this function, but this function basically returns something which is basically 10, and we can actually catch this, as you can see here, with the ret. Return stuff is gonna, we don't know what it is, and this return will be replaced, this return will be initialized with what actually is being returned. So now we can actually see this echo return value is this ret. So we print this ret on the screen. Now let's close this function. Let's make the function executable. Chmod plus x functions bash3.sh. Now the function is executable. Bash3, no such file or directory. What was the name of the function? Let's remind ourselves what was the functions bash3, right? Functions bash3. Why I have this silly sound coming by? So functions bash3. Now let's execute functions bash3.sh. Aha, okay. So I made a mistake here. Yeah. Hello world, variable 1 and variable 2, and we code the return value, which is 10, and we print it out. We are printing it on the screen. And so we have the nested functions. Nested functions are basically the functions inside of functions. So for example, we nested function 1.sh. Here you have a function, let's say number 1, nested function number 1, and inside this function you print something, echo print something, and then you actually call another function from here, let's say number 2, and you have the definition of another function here, number 2. This basically print something 2. Now from here, when you call the number 1, it's gonna actually nested function wait a minute, this is I think another function. Let's grab everything with nested. We have the nested functions.sh and nested function 1.sh, but we didn't make it executable. 1.sh. Now when you execute it, you will see that print something is printed first, and then the print something 2 is printed. which means that this number 2 is called inside this number 1 function called prompt. You can put definitions for commonly used function inside your dot profile. In my case, let's say that you want to grab everything with dot profile, right? There is a dot profile file, but this file is actually empty. Let me show you. This file is empty in my Ubuntu. I really don't know the reason. I think a long time ago I actually created this file and the file is created empty, so I just left it like that. And so anyways, yeah, I created this file today again because I actually deleted this file, and so let's create another. But in our case, this place, for example, this profile file is in Ubuntu is .bashrc. So in this file, for example, if you replace here, for example, echo I am a newly opened terminal. So if you create something like this, for example, ZZ to get it out. So when you, for example, when we create a new terminal, now we will see that I am a newly opened terminal is printed on the screen. So this shows us that when you change the information of the bashrc file, this is going to take effect when you open a new terminal. So let's get rid of this, everything. Yes. It's insertion mode, it should delete. Aha, okay. So the reason is, okay. Let's quit. Now when you open a new terminal, as you can see, it doesn't print because we deleted it. What else? You can also use the unset command. Normally when you open a function, when you execute a function from here, these variables of this function are actually loaded to the terminal. So when you actually use the command unset function name, these variables and all this stuff related to this function will not be loaded inside the terminal. So let's change. So these, the manuals of the commands, you can learn about the name, the synopsis, description, the options, see also part, bugs, examples and authors and everything. Linux regular expressions with SED. In this chapter, we'll discuss in detail about regular expressions with SED in Unix. A regular expression is a string that can be used to describe several sequences of characters. Regular expressions are used by several different Unix commands, including ed, sed, awk, grep, and to a more limited extent v. Before we start, let us ensure we have a local copy of its password text file to work with SED. Previously, SED can be invoked by sending data through a pipe. Sending data through a pipe to it as follows. So you basically show your password, and then you basically get the SED. So let us see, cat etc password SED. So using SED, SED can be invoked by sending data through a pipe to it as follows. The cat command dumps the contents of SED password to SED through the pipe into SED's pattern space. The pattern space is in the internal work buffer that SED uses for its operation. So basically, it's the piping that I was talking about a couple of days ago. The general syntax: pattern is a regular expression, and action is one of the commands given in the following table. If pattern is omitted, action is performed. For every line, as we have seen above, the slash character that surrounds the pattern are required because they are used as delimiters. deleting all lines with a cd. So when you execute with the D, you basically delete everything. Does exactly the same, cd delete in this file the addresses. It also supports addresses. Addresses are either particular locations in a file or a range where particular editing commands should be applied. When the cd encounters no addresses, it performs its operations on every line in the file. Address ranges. So there are like a lot of details here. If you're really interested in this substitution, and if you're really interested in the regular expressions, you can basically check this page. We can check this again later. Now, the file system basics. The file system in Unix. A file system is a logical collection of files on a partition or disk. A partition is a container for information and can span an entire hard drive if desired. Your hard drive can have various partitions which usually contain only one file system, such as one file system housing the file system or another containing the home file system. One file system per partition allows for the logical maintenance and management of differing file systems. Directory structure. And so basically when you open a new terminal, as you can see now, you can check wherever we are in the home and count directory. In this directory it's basically my home directory. These files are inside the home in this user space. So when I go back, actually now I have this user here, and you can, if you type who am I, as you can see I am this Khan. So, and you see if you who is whose, who is command didn't work. Who is next? Who is command. Yeah, returns the domain name, the registered domain. Okay, so we have some different directories and their descriptions. This is the root directory, which should contain only the directories needed at the top level of the file structure. This is the root directory, which should contain only directories needed at the top level of the file structure. This has the directories that actually need our operating system to function. This bin directory, this is where the executable files are located. These files are available to all users. Bin file has the executables in a Linux environment. The dev, these are the device drivers. These are basically the drivers that your devices connected to your computer needs. And we have /etc. This is the supervisor directory commands, configuration files, disk configuration files, valid user lists, groups, Ethernet hosts, where to send critical messages. They're located in this ETS file. So for example, if you want to see your log files, let's say there's been a crash in your there's been like a malfunctioning, and you want to, or let's say some process has ended abruptly and you want to see the log files of what's happened. You basically need to go to ATS, let me see, ETS here, no, log check, not here actually, it was in the let me see, in here, yeah, it's in var log. It was in what typically contains variable length files such as log and print files. So log files are inside the var directory. So what else? These are device drivers. Contains shared library files and sometimes other kernel related files. Boot contains files for booting the system. Home contains the home directory for users and other accounts. used to mount other temporary file systems such as CD-ROM and floppy for the CD-ROM drive and floppy diskette drive respectively. Contains all processes marked as a file by process number or the information that is dynamic to the system. Contains all processes marked as a file by process number or other information that is dynamic to the system. Holds temporary files used between system boots. So TMP holds temporary files used between system boots. User, used for miscellaneous purposes and can be used by many users, includes administrative commands, shell files, library files, and others. var typically contains variable length files such as log and print files and any other type of file that may contain a variable amount of data. sbin contains binary executable files, usually for system administration, for example fdisk and ifconfig utilities. Kernel contains kernel files. So these are the commands: view cat displaying a file name. So let's say you want a cat. This actually doesn't displays the final file name. So for example, you want to change directory to our sample directory. If you use the cat command in two numbers, you see everything that you see every line inside of this file. So cat doesn't display the file, it displays the content of the file. Change directory, it changes to a directory, you move to this directory. So cp, so is the copies one file to the specified location. So let's say let's go back and let's create another directory. Let's say make directory sample directory 2, and now let's come back to change directory to sample directory, and let's see what we have here. So let's say I want to actually copy this yet another loop. I want to copy this, so copy yet another loop, right? And I want to copy this file because I am inside the directory. I want to copy this one directory back and in sample directory 2. So when you execute this and when you go back to this change directory dot slash, you go one directory back, and when you go to the sample directory 2, here you can see that we have this another loop. It's copied, and file find identifies the file type. If you execute file yet another loop.sh, you can see that it's POSIX shell script, ASCII text executable. So if you execute find file name directory, so let's say go back, find yet another loop, let's say loop.sh, in which directory I want to find this in sample directory 2. Yes, as you can see in sample directory 2 I have yet another loop.sh. But first it actually printed yet another loop. Let's say no such file or directory. Head file name shows the beginning of a file. Let's clear it. If you execute head, first let's change our directory to the sample directory. Let's say head new file.txt. As you can see, this is the first line, beginning of the file. Browses through a file from the end or the beginning. So less new file.txt. This is the end. Q to quit. ls shows the contents of the directory specified. We know this. Make directory creates a directory, browses through a file from the beginning to the end. So more, if you say more new file.txt. Yeah, this is the first line inside of this folder. So, but if this file would be bigger, how can I show you that? Let's say more relational operator.sh. As you can see now, I am in the upper side, and with pressing the keys, you can actually go to the bottom. Let's clear the screen again. Moves location of or renames a file or directory. So we can actually let's move this new file.txt. Move. What I want to move? I want to move this new file.txt, right? Where I want to move inside one directory back, and I want to move inside the sample directory too. If you execute this, let's come back and go to the sample directory too. Now you can see that actually we moved this, and when you come back to the sample directory, if you execute find new file.txt here, txt in the sample directory, we can see no such file or directory. I mean, actually this means that the search is actually, this find function is not executed successfully because the syntax is not correct. Shows the current directory, the pwt, rm removes a file. Let's, in this directory, I don't want to remove here, but let's go to this sample directory too. Here we can actually remove this new file.txt. Now we removed it. Removes the directory, but let's try. If you execute remove directory, sample directory 2, remove. First we need to go one back, remove directory, sample, around the right, sample directory 2, directory not empty. As you can see, you need to actually execute remove directory rf. Recursively you want to remove. Directory 2. Invalid option. Not rf. Yeah, I usually remove it with rm remove rf sample directory 2. Now if you list and grab sample directory, as you can see, sample directory 2 actually doesn't exist because we removed it. Tail name, file name shows the end of a file, so let's go back here. Tail sample file.txt, list grep sample file, change directory, sample directory first. Here you undefined sample, something with sample file.txt, right? So tail sample file.txt, as you can see, this is the tail of it. Touch creates a file basically, so you want to create a file with touch, new file.txt, so you can actually open this new file.txt. Now yeah, we are inside of it. Where is shows location of a file, so here there is sample.txt, for example. Where is list, where is let's see the options. Search only for binaries, define binaries, lookup path. Search only for manuals and infos, define man and info lookup path. Search only for sources. output effective lookup paths. So let's go back again. Where is yeah, if you execute where is ls, you can stay inside in the bin directory. But I try to execute it, for example, shows location of a file if it's in your path. In my path, user bin new grep. Where is and which, these are really important commands. I think it would be nice to focus on these. The df command, the first way to manage your partition space is with the df disktree command. The command disktree displays disk space usage in kilobytes. Disktree in kilobytes. So for example, xdf is the file system used and the available. So for example, this is the used and the available is 63,714. So yeah, this is the size, 180 kilobytes. Let's open the files, go to the other locations. Yeah, 184.5 gigabytes. Yeah, more or less the same like here. 107 is used, so 63 is available. Yeah, so 63, 65, whatever is available. Clear. And what else we have? Yeah, it gives you the information about the physical file system name, total kilobytes of space available on the storage medium, total kilobytes of space used by files, total kilobytes available for use, this avail, capacity, percentage of total space used by files, and the mounted on what this file system is mounted on. So, and the du command, the du disk usage command, enables you to specify directories to show disk space usage on a particular directory. So enables you to specify these directories to show disk space usage on a particular directory. So for example, when I type du ats, what is the output? So the output, du help summarizes disk usage of this set of files. Let's make this a bit bigger. Summarizes usage of the file, of the set of files recursively for directories. Displays values are in units of the first available size from block size and the du block size. Okay. The number of blocks consumed by each directory. A single block may take either 512 bytes or 1 kilobyte depending on your system. So this takes basically 10 blocks, displays 126 blocks in the disk. The age option, yeah, make it human readable. This is the K here, the kilobytes. Yeah, mounting and unmounting. So I think that's enough. I mean, in the next slide we have about the user administration in Unix and Linux operating systems. So thank you for watching. If you guys enjoy my video, please subscribe to my channel. I'm just trying to learn